Hello and good afternoon, CSI257 Section 847 students for the first 8-week term of the spring 2015 semester, and this is the Cisco Networking Academy Scaling Networks course, which is Anne Arundel Community College's Networking 3. And today's PacketTracer tutorial is going to be on PacketTracer Activity 6.2.3.7, which is almost a direct reflection or a direct duplicate of PacketTracer 6.2.3.6. However, here we're going to be using IPv6, so OSPF v3, in order to achieve the results that we're looking for. So let's go ahead and jump right in. Part 1 is configure OSPF v3. So we need to enable IPv6 routing in order to be able to configure OSPF v3. So let's go ahead and do that. We'll start with router A, and let's pull these down here and then make them a little larger here. And let's pull up router B. So we'll get all three routers set up here. That way when we're moving back and forth, we can do it quickly and we don't have to resize each time. And we've got router C. Alright, so we're on the CLI here, and we'll just start with router C. We'll go from user exec mode into privilege exec with the enable command, and then into global config mode with the configure terminal command. And so the command to enable IPv6 routing is simply IPv6 unicast routing. And so let's do that on router B and router A as well. So we'll go from privilege exec to, user exec to privilege exec into global config, and we're going to say IPv6 unicast routing, and then over here onto router A, user exec to privilege exec, and then global config IPv6 unicast routing. Alright, so we've enabled IPv6 unicast routing on all three of the routers we're going to be working with here, and the next step is to configure OSPF v3 on RA with process ID with a process ID of 1 and the router ID of 1.1.1.1. So if I type in IPv6 router, you can see that we have IPv6 router OSPF, and the IPv6 configuration is very similar to the IPv4 configuration. However, we precede the command with IPv6. So I'm going to type in IPv6 router OSPF, and it's asking for us to use the process ID of 1. And now it says OSPF v3 process 1 could not pick a router ID. Please configure one manually. And so we know that the router ID it's looking for is going to be 1.1.1.1. Alright, so we've got that entered in there. And the next step is step 2. And it's asking us to configure each active IPv6 interface with OSPF v3, assigning each to the area listed in the addressing table. So let me scroll back up here. We're on router A. So let's go ahead and go into interface gigabit. The first one's going to be 00, and we're going to say IPv6 OSPF, and we're going to do process ID of 1, and that's the process ID we're using, then the area, right? And so this is very similar to, and even though the curriculum doesn't cover it in the Scaling Networks course, specifically what I'm referring to is with OSPF v2, being able to configure OSPF under the interface. So what Chapter 6 shows us, or Chapter 5 I should say, and 6 show us how to configure OSPF with the network statement under the global router OSPF configuration. However, you can do what we're doing right here with IPv6. You can actually do this exact same thing with IPv4 by simply configuring the OSPF process and area number under the interface, and then the OSPF process will start on that interface. So IPv6 OSPF, and our area on that interface is area 1. And now let's go into gig 10, or 01 actually, and we're going to say the same thing. IPv6 OSPF 1 area 1, and then let's go into serial 000, and we're going to say it's going to be a little different here. IPv6 OSPF 1 area, and that's in area 0. So that interface is in the backbone area. All right, and as you can see, we've just finished up on router A, and we're already at 40 out of 100%. So it looks like as we walk through each of the routers here, it's going to substantially increase our completion percentage as well as the points that we're earning here. Okay, and as you can see on router A, it looks like out to the cloud out here, and let me roll this up just a little bit. All right, trying to keep it so we can see everything. All right, there we go. So with router A now, you can see that we've got 2 adjacencies that have popped up with neighbor 11.11.11.11.11 and then 12.12.12.12. Now the key here is to remember that even with IPv6, the router ID is still going to be a 32-bit value in IPv4 address format. So even though we're doing IPv6, your router ID with OSPF v3 will always be 32 bits in the form of an IPv4 address, and that's why we're seeing the neighbor, when the adjacencies come up here, that's why we're seeing it as the IPv4 address. This doesn't mean that the neighbor, the IP address of the neighbor that we're creating the adjacency with is 11.11.11.11, because again, we're using IPv6. In fact, let's do a do show IPv6 interface brief, and as you can see, our gig 00 and our gig 01 are both configured. They're up and up, and we have IPv6 addresses assigned. If I do a do show IP interface brief to take a look at the IPv4 addresses, you can see it shows that the interface is up, right? But that's because the interface is in an up status. There is no IP address assigned. We have no IPv4 addressing at all here. And so that's something to take into account, is that if I were to do show IP OSPF neighbor, we don't see anything. Because again, do show IP is inferring or implying IPv4. If I wanted to rerun that command and I want to see my IPv6 neighbors, I would take a look here. And as we've already stated, this is the router ID of the neighbor, right? And so as a quick review here, this is our router ID. The default priority for the DR, BDR, or I should say the default interface priority when you have a broadcast network type in OSPF, is the default priority is going to be 1. If this was a serial link, we would see it as 0. And on router A here, it looks like we will as soon as we bring up the interface on router B that connects to router A. And then we have the dead time, right? And so as you watch the dead time drop, 35, 34, 33, it's going to get to 30, and then it's going to go right back up to 40 and then start counting down again. Because remember, the OSPF hellos are coming in on a 10-second interval. And so for me to see that, if I said do show, and I'm actually drawing a blank all of a sudden, if I were to do the do show IP OSPF interface gig 00, oh, I'm sorry, do show IPv6, there we go, I quickly forgot IPv6. So if I do the do show IPv6 on the interface, you can see here that our hello interval is 10, our dead interval is 40, and so these timers need to match, right, with OSPF. So when we get into chapter 7 to look at EIGRP, that's where the timers do not have to match for the adjacency to come up. So again, if I were to go into, let's go into interface gig 00, and I were to say IP OSPF IP OSPF hello interval, and if I were to change this, we're going to watch the adjacency tear down just like we did in IPv4. So I'm going to change it to 5. So now if I run that command again, do show IP OSPF IPv6, so used to IPv4, IPv6 OSPF neighbors, let's watch our hello timers now. So we caught it at a good time. So as it counts down, 31. But watch what happens on gig 00. Oh, and it's not going to cooperate with me here, it doesn't look like. And this again, possibly a limitation with PacketTracer. I've made the change, yeah. So it doesn't look like it's going to take it. But we saw with IPv4 where those timer values, if they don't match, let's do a do show run, make sure that it shows up in there. Let's see if it even took it. Yeah, so it did take it. Let me do, let's do a do clear IPv6 OSPF proc. So let's clear the process and let's see if that has. So there's the neighbors, and we definitely have different timers than the neighbor does on gig 00. Let's see if that tears down or if it's going to, no, it's just going to go up. All right, so we'll take it off of there. But again, we saw with IPv4 within the PacketTracer where that is actually going to cause an issue. So I'm going to say no IP OSPF, hello interval 5. So if I do a do show run now, we should see on gig 00, we're back to our original config. Okay, so that is router A. Let's go ahead and jump over and knock out our configuration on router B. And where do we leave off? So each of the interfaces. So here we go. Let's jump into, but it didn't have us configure. There we go. Okay, so repeat. We're going to repeat the same steps. I was looking at step 2, but that was really only talking about router A. So now I'm down to step 3. Toward the bottom here, and I can actually roll down a little bit. So I'm down to step 3 now, and it says do the same thing for router B and router C. So let's do that now. So if I were to say IPv6 router OSPF, and then again the process ID looks like it's going to be 1 around the board. And again, first thing I need to do is set my router ID, and for router B, we're going to be 2.2.2.2. And then let's configure OSPF on the interfaces for router B, starting with gig 00. So we enable it globally with IPv6, and you can do this with IPv4. It's just that the text for scaling networks didn't really demonstrate that. It showed it with the network statement, and that's not how you do it with IPv6. With IPv6, you do it under the interface. So I'm going to go ahead and say IPv6 OSPF1 area, and the gig 00 is area 0, and then let's drop into serial 000, and my guess is that this, when we rerun that command right there, is going to pull the adjacency up between router B and router A, and I'm going to go ahead, and there it is right there, and let's do a do show IPv6 OSPF neighbor, and that's one of the biggest challenges for me is to always remember to put that V6 at the end, because I'm so used to typing just, show IP OSPF neighbor, show IP OSPF interface. So here we go. So here's our adjacency with router A, right? He's a neighbor of ours. And as you can see, on a point-to-point broadcast type, the priority value will be 0. And it looks like we're establishing our adjacency out here to the quote-unquote cloud. And again, when the priority is 0 on a point-to-point link, point-to-point network type, your DR-BDR election is not going to take place. So we see full adjacency, right? And we have no DR-BDR. With the router whose ID is 21.21.21.21, we have a two-way adjacency, and we see it as a druther, right? DR other. So we don't see it as a DR or BDR. It's a druther relationship. Okay. So let's go on to the last interface, which is going to be serial 001. And again, it's going to be that same command, IPv6 OSPF area 0. And they list a link local up there, and I'm curious, do show run. Are we supposed to be adding in that link local? Let's take a look. FE80::B. No, it looks like that's going to be in there. FE80::B. Okay, so it looks like the link locals are in there already, and I just realized they're in the addressing table here. I wanted to make sure that we didn't need to add that in. So let's finish out here with router C. and we're going to go from user exec into privilege exec with the enable command, and then configure terminal to get into global config, where we're going to say IPv6 router OSPF with a process ID of 1. And again, we're very used to this message right now. We know we got to get a router ID in here, and for router C it'll be 3.3.3.3. So now let's go ahead and, in fact, if I were to type a question mark, you can see there is no network command, right? So hopefully you can see that. So with IPv6, or I should say with OSPF v3, which is with IPv6, when you're configuring OSPF v3, there is no network command here under the global router config area. So this is why you have to do it under the interface. And so I'm going to pull up, this is actually a real Cisco 1841 router, even though it says 819W, it's actually an 1841 router. And let's go ahead and take a look here if I were to do the same thing. So I'm going to, let me get out of the, drop down into the tab down there. So if I were to say config T IPv6 unicast routing, and then IPv6 router OSPF 1, is there a network command here with the legitimate OS? And as you can see, there's not. So it's not that it's something that maybe PacketTracer didn't incorporate. The network command under the global OSPF v3 configuration area, there is no network command, right? So it's got to be configured under the interface. And I'm doing, what code am I running here? This is 12.424T2. So remember that. And again, it would have been nice had the text touched on this with the IPv4, that you can do the same thing with IPv4, in fact. So if I were to go into do show IP interface brief, let me just pick an interface here. Let's do fast Ethernet 00. So if I were to say interface fast Ethernet 00, for IPv4 you simply type IP OSPF, the process ID, and then the area number, right? And that's it. So you can do the same thing with IPv4. And again, the book didn't mention it, but you can certainly do it, and it's very, it's much more convenient way to do it. It gives you more control as well in sort of a shorter amount of keystrokes in terms of which interface is going to be running the OSPF process in which area. All right, so let's come back to PacketTracer here, and again, as you can see, there's no network command. So let's go ahead on router C now and jump into the interfaces here. And let's run our command, IPv6 OSPF 1 area, and for gig 00 on router C we're area 2, and interface gig 01 we're also area 2, and for interface serial 001 it looks like we're going to be area 0. So this is our connection into the backbone area. So again, router A and router C are ABRs, right? And we'll actually take a look at that here. Let me run command real quick, get this last one in here to bring up the adjacency. So if I were to say do show IP OSPF, we get nothing. Again, I keep forgetting this V6. Do show IPv6 OSPF and hit enter. This is going to give us information about the OSPF connectivity that I currently have on here. And you can see that it's, whoops, I'm getting some messages here that are popping up. As you can see, it tells us the OSPF process ID is 1. It gives us our router ID. It's also going to give us the number of areas that in this router. It's 2, right? And they're normal areas, no stubs and no not so stubby areas. It tells us what the reference bandwidth is. Gives us the number of interfaces that we have in each of the areas to which we are connected. And there's one thing I'm looking for that I don't see, and let me see if we see it over here. Do show IP OSPF. And it should say, maybe I'm not looking in the right spot. Here, let me check on router 5, which is an ABR and an ASBR. So show IP OSPF, and I may be completely overlooking. Yeah, so it is. Did I look right by it over here? Let me see if I totally missed this. So it is, yeah, so you don't see that here, even though we're on router C, and router C is clearly an ABR. Let's run the command again. Yeah, and it might be, and again, I don't see it here, but let me come over here. So typically what you'll see when you do the do show IP OSPF, you can see with each process, it's going to tell you what the role of the router is. And so it'll tell you it is an area border, and this is in this specific case, this router is doing both functions. It's an ABR and it's an ASBR, right? So it'll tell me what it is. And let's see. Yeah, so and if it's not, right, if it's not an ABR, it's not going to say, it doesn't say anything, right? Because it's only going to tell you if it's an ABR or an ASBR, if that's the role that it's serving. And so I was anticipating we were going to see that here on router C. We don't. And I want to make sure I point that out, because that's definitely a good command to know. Do show IP OSPF, do show IPv6 OSPF. And typically, again, what you'll see is it should say, and you can see that it's a much consolidated version of output here with PacketTracer, and that's why I wanted to make sure I pulled this up. And as you can see, you end up with a lot more information with the real iOS, and specifically, and I'm having a hard time locating this again, specifically right there, it's going to give you the role of the router, and our process ID is 99 there. All right, so let's drop that in the background. So it's good to keep that in your back pocket to be able to help you out with the role of the router. Okay, so for router C, that is it. We've completed all the steps there. So part 2, verify multi-area OSPF v3 operations. So verify connectivity to each of the OSPF areas. So from router A, we're going to ping, and it's asking us to ping each of the devices in area 0 and area 2. So 2001:db8:, what do we have there? 1:b1::2. All right, that worked out great. And let's roll back here to A1::2. And we have connectivity there. And then A2::2. How about C1::2? And we're good there. And then C2::2. All right, fantastic. So we've got connectivity. We've got some show commands as well. So we just saw the show IPv6 OSPF. Let's take a look at show IPv6 route. What do we see? And let me make this a little larger here. Bring it right up to there. So what do we have here? We've got our IPv6 routing table. Excuse me. You can see that we have some intra-area routes, right? The intra-area routes are routes that are in the same area that we're in, right? Or the interfaces in that area. But then we have some inter-area routes as well. And we still have this same table up here, right? So the OI is OSPF inter-area, and the O is the intra-area. So on router A, he's learning about 2 inter-area routes from C1 and C2, which are these 2 networks over here, right? So what's going to happen is there's going to be a type 1 LSA generated by the router or routers in area 2 that router C is going to learn. Upon learning those type 1 LSAs, what's going to happen is router C is then going to generate a type 3 LSA and send that into area 0. And that's your summary LSA. So then router B and then router A are going to see that information, and that information is going to get passed along into area 1 as well as area 0. So when we come into area 0 here on router B, what we should see is router B should have 4. If we do a show IPv6 show IPv6 route, Router B should be learning about 4 inter-area routes, right? The 2 inter-area routes from area 1 for A1 and A2, which are these 2 routes here, as well as the 2 inter-area routes over behind router C, C1 and C2. Because remember, area 2 and area 1, within these areas, each router is going to generate a type 1 LSA. The ABR will learn about those type 1 LSAs. He will then generate a type 3 LSA into area 0, a summary LSA. And remember, it's summary, but not summary in the sense of routing summarization. That's not what this is. So like if you were to take 4 subnets and try to figure out, okay, can I consolidate this into a single subnet? That's not what this is. What it is, it's the description of the LSA. It's providing summary, a summarization of the information from area 1, but it's a summary with respect to the link state database, right, or the OSPF information in that area, and you're given a summary of that information. And we talked about that in class today, where if you think about it, so you have a type 1 LSA for all of the routers here in area 1. When that gets learned by router A is going to send in a type 3 LSA. Whoops, left out the 3. Type 3 LSA is going to be sent into area 0. And this is a summary LSA because it doesn't have all the complete information that the type 1s are carrying. So if you think about it, what kind of behavior is this? Where information in this area over here is hidden from area 0. So all router B knows is that if I need to get to any of these networks, I just send my traffic to router A. And that type of behavior is definitely distance vector, right? So today we talked about chapter 7, EIGRP, where in EIGRP, the router just simply needs to know, does the router I'm connected to have a path to this network? And if that's the case, then I send him the traffic. I really don't care about what's going on once the traffic gets behind him or gets beyond him. And so this type 3 summary, I mean, this is really distance vector behavior if you think about it. Because type 1 and type 2s in here, you're going to get all of the information for all of the links that are in this area. But as soon as we basically segregate the areas and say, okay, area 1 here and area 2 here, to area 0 from these 2 areas is simply a summary, right? It's a hiding of the information of all of the complete information from these areas is being hidden from area 0. Now, it's not I'm not saying it's a good thing or a bad thing. It's just simply it is what it is. But that behavior is distance vector behavior, okay, at its finest. So let me clear the screen here. And when you get to chapter 7 and chapter 8, think about that. Give that some thought that that's actually what's occurring. All right, so let's do the show IPv6 OSPF database. And as you can see, the database, this is going to look very, very similar to the OSPF database with IPv4, right? Because one of the things that should be very common or familiar to us right now are the router IDs, right? So these advertising routers, these are the router IDs. Now, we do end up with some IPv6 information in here, obviously for the prefixes, right? As well as the prefix length. Remember that that is not a subnet mask. That is the prefix length, right? Very different from a subnet mask. And we also pick up some new LSA types. So we have a type 8 LSA, right? And again, you can see the intra-area prefix link states, and we're on router B, who is in area 0. But then we also see, here's his type 2 for the network link state, right? The network LSA type 2. Here are the router LSA types that we saw at the very top, right? So it should be very familiar to you. And then if we were to do show IPv6 OSPF interface, you can see that we end up with a lot of the same information. And so here you go. Here's our point-to-point interface, which is our serial link. You've got your hello and your dead intervals. And so the show IP OSPF interface command is also going to tell me what is my role, right? So on gig 00, router B is the BDR, and that's out here to this cloud above him. You're not going to see that on either serial 000. And see how it says state BDR priority 1. What does it say down here? There is no priority, so it says state point-to-point. Because remember, these are point-to-point links. There is no DR BDR election on point-to-point network types, right? Okay, and then finally, let's do the show IPv6 OSPF neighbor, and we've done this already. And again, you can see here, priority is going to be 0 on the point-to-point network types because there is no DR BDR election. Our default priority on the broadcast network type is 1, and as you can see, a DR has been elected, and then here there was no DR BDR election. We've got our dead timers, the interface IDs. All right, so, and what does it say here? PacketTracer output for show IPv6 protocols is currently not aligned with iOS 15 output. So let's take a look at that actually real quick. So if I were to say show IPv6 protocols, you can see that we get OSPF 1, neighbor discovery connected. So interfaces just gives us the interfaces, the redistribution. I have 15 code here on this guy here, although he's not running. I don't believe I'm doing anything IPv6 related. Let's say IPv6 unicast routing, and then let's give it a shot here. Let's just say, I guess I could configure it real quick. So let's say IPv6 router OSPF 1, or we'll say, I'm not sure if I'm already using something like that. So let's just do that. We'll say router ID 1.1.1.1, and I'll do show IP interface brief. And then from right here, let's just do the do show IPv6 protocols. And yeah, that's pretty much all we get. I guess the difference was the number of areas. And so it doesn't give us the number of areas, which we do see here. But other than that, it's pretty close. So, but they, like I said, they give you a little notification down here. And it looks like that might be the only difference. Again, I'm not running IPv6 over there on this router here, which is running do show version 15.3, right? So, and again, it clearly doesn't look like it's that different. What if we were to do show IP protocols? Or, I'm sorry, show IP OSPF protocols. And what am I missing here? Show IP protocols. Oh, do show IP protocols. Thought I had the command wrong. Do show IP protocols. There we go. So we get much more information here when we do the show IP protocols when something's actually running. And so my guess is if I were to enable IPv6 on an interface, which this now has me curious. So let's do a do show IP interface brief. Let me jump into FA00 and say IPv6 address is going to be FE80::, and we'll just say : 1 link local. So we'll give it the link local, and I'll say IPv6 OSPF 1 area, or actually it was OSPF 100 area 11, right? And now let's see if I do a do show IPv6 protocols, if we get some additional output. Yeah, there we go. So a little additional output, right? Not a whole lot, but a little additional output with OSPF running, actually running on an IPv6, OSPF v3 with IPv6 running on an interface. All right, So that wraps up PacketTracer activity 6.2.3.7. Remember that we have 4 PacketTracer videos this week. Some very good stuff with EIGRP, and we're also going to be doing some EIGRP v6. Okay, I hope you've enjoyed this video and it's cleared up any confusion that you might have. And best of luck with your studies, and I will see you next Saturday.